I'm going to talk in this video about what an arithmetic sequence is. And an arithmetic sequence is a pattern of numbers that increases or decreases by the same amount called the common difference. Okay, so it's something that increases or decreases by the same amount called the common difference. And to look at an arithmetic sequence, we can look at an example here of the even numbers would be an arithmetic sequence. 2, 4, 6, 8. Each time you go from one number to the next, you're increasing or adding 2 each time. So that's an increase of 2. In this case, the common difference, or D, would be equal to 2. Okay, now if we look at this lower one here, this is also arithmetic. Each time you go from one number to the next, every single time, you're decreasing by 3. So each time you're subtracting 3. So in this case, D would be -3, or the common difference would be -3. Now here's some examples of some non-arithmetic sequences. A non-arithmetic sequence is a sequence that would, this is actually called a geometric sequence where you're multiplying by the same number each time. So here, sure, we're multiplying by 2 each time. But if you look at what we're adding, here we're adding 2, here we're adding 4, here we're adding 8, and so on. Okay, you can see that we're not adding the same amount every time, so this is not an arithmetic sequence. Okay, and then we'll talk about this last one here in a little bit. I have this example on a later slide, so let's go ahead. And arithmetic sequences, if you were to graph the term number that you had, whether you had the first term, the second term, the third term, and so on, and then you had the value of the sequence at that point, they would, if you graph them, and I'm just kind of making up an example here, they would make a nice straight linear path. So they would work just like lines. And we'll talk about their connection to lines in a little bit. Okay, so what we're going to do is look at each of these sequences, find the next 3 terms, and identify if it's arithmetic or not. Okay, so we'll start with this first one. And if you look here, if we look at the difference here, this is an increase of 2. This is an increase of 2. That is also an increase of 2. So if we were to find the next 3 terms, and we can kind of see that, yes, this is going to be an arithmetic sequence because it's always increasing by 2. This should be 9, 11, and 13. Okay, so that would be the next 3 terms in the sequence. And yes, this is arithmetic because it's adding on the same amount every single time. All right, we're going to look at the next one here. And if we check, we're finding the difference between each of these, and I'll let you, if you want to pause the video here, go ahead and find the difference between each of these, and let's see if it's arithmetic or not. Okay, and if you took the time to do that, you can see that each of these has a difference of 12 each time. So we're adding 12 onto each of these. So the next one here would be 55. Okay, plus another 12 would be 67. Plus another 12 would be 79. Okay, and that would be the next 3 terms in that sequence, assuming I didn't make a little math boo-boo there. We'll look at the next one. So 2, 4, 8, 16. We already said on a previous slide, this is a difference of 2. This is a difference of 4. And this is a difference, let's change that so it looks more like a plus sign. This is a difference of 8. And you can see here that this, sure, you're multiplying by 2 every time, but you're not adding or subtracting the same amount. So no, this is not going to be arithmetic. So this one was yes. This next one is no. And if we were looking for the next 3 terms, we just have to double the result each time. So in this case, 16 times 2 is 32. We'd have 64, and then 128. Okay, and I'm going to skip this next one. I'll tell you that it is arithmetic, and it is subtracting the same number every time. But I'm going to leave that to you guys to go ahead and see what number it's subtracting by every time and find the common difference. I'm going to skip right here to this 5th one. Okay? If we're looking at this sequence, this is actually a famous sequence of numbers called the Fibonacci sequence. And what happens, it actually originated with a problem dealing with rabbits. And I'm not going to go into detail about that, but what we'll do again is look at the difference each time. So here the difference is 0. There's nothing between 1 and 1. Here the difference is 1. So already we can tell that this is not arithmetic. Here the difference is 1 again, and again I'm going to stop looking at the differences here. Let's just try to find the pattern in the sequence of numbers. And again, if you want to pause the video here and try to find the next 3 terms in the sequence, this is not an arithmetic sequence, but I'll let you see if you can find the pattern. So take a second, pause the video if you want to see if you can find it. Okay, and if you took a second to pause the video and find it, the way we look at the Fibonacci sequence is if we add the previous 2 terms in the sequence, we get the next term. So 1 plus 1 is 2. If we look at the next 2 here, 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. And now if we're looking for the next term, 5 plus 8 should be 13. Now to get the next term, we're going to have to do 8 plus 13 would be 21. And then finally, to get the third term, 13 plus 21 is going to be 34. Okay, so the key here being you're going to have to add each of the previous 2 terms to get the next term. And I know this video is on arithmetic sequences, but it's important to be able to recognize patterns as well as tell which ones represent something that's arithmetic. And we said that arithmetic sequences function like lines. And I'll talk more about that in my next video on applying these to word problems.